Welcome to Geometry 1, everyone. Go ahead and hit the pause button, and if you need to write down the definitions in red, please do so now. Otherwise, I'm going to keep going. Alright, so we're going to jump down to our problem-solving strategy. Now, in this first unit, there are many definitions, okay? So it helps to make flashcards or to review your notes and just kind of go over each term and understand what each thing means. And of course, it always helps to draw a picture. That seems to help. And sorry up on top, this is not spelled right, but I can't change it. So you're going to have to get past the extra E. All right, we're going to start with our problem solving, and we're looking for a certain pattern here. Let me click on the pen and let's go blue, and now I'm ready to write. So let's draw an arrow from A, and we're going to draw this A and this arrow from A all the way down, because what we're doing down here when we find a pattern, that's known as inductive reasoning. So that's what we're going to do to solve this problem. Then underline the term conjecture, all right, and then draw this line from D, and that's going to go into this column. All right, this is our conjecture column. And what conjecture means is it's the rule that we go by explaining or defining the pattern that we see. For example, we see 1, 4, 7, and 10. Well, it looks like we are increasing or adding by 3. So we're going to put 13 and 16. So my conjecture or rule would be add by 3. Okay, next we have 1, 4, 16, and 64. So think about how we went from 1 to 4, from 4 to 16, to 16 to 64. It looks like we are multiplying by 4. So let's put that, multiply by 4. And so that would be 256. And this would be, I believe, 10,024. Might be off by a little bit, but you get the idea. On C, we have Sunday, Monday, Tuesday, Wednesday. So the pattern are the days of the week, Thursday and Friday. So our conjecture or the rule is going to be days of the week. And then last we have 1, 8, and 27. And at first you might think, hey, I'm not really sure, I don't see that pattern. Well, let's think about 1 to the third power is going to be 1. What about 2 to the third power? Well, 2 to the third power would be 8. And then 3 to the third power would be 27. So it looks like we're doing cubes, or I can show that as n, our number raised to the third power. And so 4 to the third power would give me 64, and then 5 to the third power, that's going to give me 125. Alright, we're going to scroll down, keep moving here. We have a point. They want us to draw a name. So a point, we can just put a point, and let's put point P. Alright, and I can also say that this is point P. Alright, or we can have point X or point L or point anything. A line is going to extend in opposite directions without end. So a line is going to continue on forever. We need at least 2 points. Let's put point A and point B. And the way that I show this is I can say that this is line AB. We show it with arrows on top. That's line AB. Or I could say line AB. Okay. So there are 2 ways that we can name a line. Or I could put a T up here, and I could say that this is line T. So again, there's more than one way to label a point, more than one way to label a line. Next, a plane. A plane can be any shape. Let's draw a parallelogram, and we're going to say that this is our plane. Now, a plane is going to extend forever. So even though it appears that the plane is only this space in here, it's actually going to continue on forever. And so this would be our plane, and let's put, there's always at least 3 points in a plane that are non-collinear. So let's put point A, point B, and point C. And so I could say that this is plane ABC. I could put a Y right here, and I could say that this is plane Y. So again, there's more than one way to express a plane. Usually we'll show a plane with 3 letters. So if you see ABC, that would refer to plane ABC, not line ABC, because on a line you only need 2 letters. A plane, you need 3. Alright, and then moving down below, we also have this drawing, and they want us to name 3 points that are collinear. Well, the term collinear means on the same line. So hopefully you can see point B and point A and point G. So let's call that, name 3 collinear points, B, A, and G. Those 3 points are on the same line. Next, name 3 non-collinear points. Well, this time let's go B, let's go A, and we'll include E. Okay, or I could say E, A, and L. Right, so again, there's more than one answer that works here. Are G and E collinear? Let's put a star by this. This is visually confusing, and here's why. You look at GE, and you don't see a line through these 2 points. However, there's a rule in geometry that says through any 2 points, there exists one line. So even though you don't see a line through G and E, through any 2 points, there exists one line. You could draw on your own line. And we'll try to make it as straight as we can. And so this is going to be yes. Hello, and welcome back to geometry. We're going to start with the intersection of 2 planes. Actually, we have through any 2 points, there is exactly one line. So let's show that with our points. Let me click on the pen. And let's get the right color. Let me go with the blue. Alright, so let's put point A on this line. And I'll put point A right here. And we'll put point B on the line as well. And doing 2 points, we can draw a line, and it's line AD. Moving down below to our 2 planes, here we have plane X and plane Y. And we're being asked, what is the intersection line BI and O? Well, I don't see line BI, so we have to draw in line BI ourselves. I'm going to draw this in. Try to make this as straight as we can, not perfect. And we'll put arrows for signifying that it's a line. And so these 2 lines, here's an O, intersect at point W, so we can just put point W to the right. Next, are lines BW and R coplanar? Are they on the same plane? Well, BW is on plane Y, and NR is on plane X. So these are not coplanar. You say no. What about OW and I? Well, through any 3 non-collinear points, there exists one plane. So even though, let's put a star by this problem, because this is a visually confusing problem. When you look at point O and point W and point I, actually this one is not visually confusing, that's easy to see. Point O and point W and point I are on the same plane. Alright, so we'll get rid of that star. But we will start question 4. This is the one that's visually confusing. R, B, and I. Here you have point R in plane X, point B in plane Y, point I in plane Y. So at first it appears that these 3 points are in separate planes, and they are. However, we have a rule that says that any 3 non-collinear points, there exists one plane. So we could actually draw in our own plane that would include R, B, and I because it's 3 points. We're going to say yes for this one. Number 5, what is the intersection of plane X and plane Y? Now first, you might be thinking, what is the intersection of point X and point Y? But these aren't points, because 2 points can't intersect, they would be the same point on top of each other. So this is referring to plane X and plane Y. And two planes always intersect in a line. So the line would be plane X, plane Y, which times by the line, that would be line in O or in W, so I can show this as in O, we show with arrows on top. Okay, or the same line is in O, I could call it OW, and that would be the same exact line. And how about a third way? A third way would be in W. That would be a third way that we could write these lines. Alright, go ahead and hit the pause button and then write down the following definitions. And then I'm going to go ahead and get started on the next section. So we're being asked true and false. And sorry about that, let's scroll back down. We have plane SIE. So hopefully you can see this plane is a triangle plane. There's SIE, it forms a triangle. Alright, so are SI and E on the same plane? Yes, they are. Through any three non-collinear points, there exists one plane. Question 2, we have are E and G on the same line? So I'm going to put another star by this because this is visually confusing. Let me change the color. Let's grab the pink color. Alright, so hopefully I have pink now. Let me check. Yes, I have pink. Good. So E and G. Well, as it sits, I don't see a line that will connect E and G. So let's draw in our own line. So here comes line EG, and then there. So there's line EG. And so this is actually going to be a yes because through any 2 points, there exists one line. So even though you don't see the line, you can draw on your own line, just like we can draw on our own plane. Alright, next, G and L intersect I and G. So G and L, let's change colors again. Let's go to yellow. And we go up here, G and L, let's highlight. This is plane G and L. Alright, there's that plane. And then I and G, I and G would be this rectangular panel on the side, I and G, and actually S, right, I and G S. And so you see where these 2 planes intersect, and let's change the color one more time. Let's go to red. And these 2 planes will intersect in this line, and that line is in G. So I'm going to put line in G and arrow over it. Alright, the next we have S, G, and L. We're being asked if S, G, and L are on the same line. Here's S, here's G, and L. They are not on the same line. That one's pretty easy to see. We can say no. Line IE intersects SG. Alright, so line IE and SG. No, I'm going to put a star here. These are called skew lines. Alright, and they're lines that aren't parallel, but they don't touch either. So you can see that line IE is on the front. Here's line IE, it's on the front of the shape. Line SG is on the side. And these 2 lines do not intersect, but they're also not parallel. And so that's what is known as skew lines. So this is going to be a no. Say no here. 6. Line GL intersects in G at point G. So GL and G, yes, these 2 lines intersect at point G. That would be a yes. And are E, G, and N coplanar? E, G, and N. And again, let's put a star here. This is visually confusing. But E, G, and N, they appear to not be on the same plane, but actually they are, because through any 3 non-collinear points, there exists one plane. So I can put a yes here. And then last, we have L, I, N, S. Are these 4 points coplanar? So L, I, N, so L and N would be here, and I and S. And so those are 2 separate planes. And we don't have any rules about 4 points. It's only 3 non-collinear points. So these points are in 2 separate planes. We're going to say no. These are not coplanar. Alright, and then down below, we have our line to MA, so let's draw a line to MA, and you can do this in many ways, but, here's point M, and let's put point A. Intersect HI, so here's H, and here is, point I, and actually we need to make this a line, so let's extend this out, there's the arrow, extend this out, and there's our arrow. And these are going to intersect at point T, so there's our point of intersection, and we can put point T. Alright, last problem, non-intersecting planes cat and dog. Now, we want to draw this in 3D, okay? To draw a 3D shape, we're going to draw a box or a square within a square. There's one square, there's our second square, and then we just connect the lines. So we draw that line, that line, that line, and that line. And non-intersecting planes cat and dog, I'm going to change this to blue. I think this will stand out better. Let's have cat be our ceiling. So this is the ceiling of our shape. It's the plane. And let's say that we have cat and C, and let's put A here, and let's put T here. Now, T can be anywhere. I could put T in our box on the ceiling, like inside, or I can put it at a vertex, okay? So it's your choice. And then dog can be on the floor. So let's put D, and this time let's put O in the center just to mix it up a little bit, and then we'll put point G over here. So we have a plain cat, and then we have a plain dog, and we can see that these two planes don't touch. They are parallel.